For this project, we used the heat energy from 2 boiling cups of water to take 8 quarters and lift it up 2 inches. To accomplish this, we used the water to heat the inside of the bottle with a plastic membrane attached to the lid. This plastic membrane was capable of inflating as the air inside the bottle got warmer and it expanded. We used this expansion to lift up the quarters. We used the formula eta equals W over QH, where W represents the work done by the system and QH represents the total heat transfer. To determine W, we used the work formula integral from V2 to V1 of P times delta V. Because the weight of the quarters acts as a piston on the system, we can assume that during the course of expansion, the pressure in the system is constant. In addition, because it was loaded under atmospheric conditions and prior to the experiment there was no vacuum within the bottle, it is safe to assume that the pressure is equal to the atmospheric pressure. Thus, we can simplify the work equation into W equals P times delta V. To determine delta V, we used how the expansion in our experiment worked. We used the tip of a glove that would start off fully sucked into the bottle and end fully extended out of the bottle. Because of this, we know that the change in volume must be equal to 2 times however much volume this glove could hold. We calculated this to be equal to 4.06 times 10 to the negative 5th cubic meters. In addition, the atmospheric pressure on the day of the experiment was 101.02 kilopascals. Thus, the work done by the heat engine is 4.1 joules. To determine the heat of the system, we use the formula Q equals M times Cp times delta T, where M represents the mass of the water, Cp represents water's specific heat, and delta T represents the change in temperature of the water. The mass of water is given by simply knowing that we have 2 cups of water available and using the density of water. To determine delta T, we use the properties of water at the start of the experiment and measure the water at the end. In the beginning of the experiment, the water is boiling, thus its temperature must be equal to 100 degrees Celsius. At the end of the experiment, we are interested in measuring exactly when expansion stops in the system. To do this, we used a thermistor which determined that our final temperature was 89.95 degrees Celsius. Thus, we were able to determine that the total heat into the system was 19.8 kilojoules. Lastly, to determine our overall thermal efficiency, we simply divide the work done by the heat input. This gave us a value of 0.0207%.
The design is very simple. Starting with a slightly warmed bottle, a rubber band is added at the top to work as a gasket. A glove is then added and sealed with a rubber band so that the result looks like this. The pen with the coins on top is then put inside the hole, and a paper towel tube is used to provide stability. The only component that I had to buy was a thermocouple. I had the bottle of soy sauce that was empty in my fridge, and the gloves, rubber bands, and paper towel tubes and tape I had lying around. The thermal efficiency of the engine. This thermocouple pulls the temperature of the water using this Arduino. The temperature is pulled every quarter second. To measure the expansion, the initial position and final position of the coins are marked on the paper towel tube. During the design process, multiple problems arose. The first problem was that plastic bags like these were used. The problem with these is that they would expand outward instead of upward, and they were hard to seal to a container. Instead, I used the finger of a glove. This could only expand upward, and I added a rubber band to the top of the container to function as a gasket. Next, containers that were too small in volume were tested. To get enough expansion, I needed a larger container, so I used this soy sauce bottle I had in my fridge. Next, I was getting more expansion than the glove could handle. So to get around this, I let the glove be sucked inside the bottle. Then when it was heated, I would get the expansion to neutral and out of the bottle.